All right, folks, this is our last operation with rational expressions. We are now going to learn how to divide rational expressions. And dividing rational expressions is pretty much the same thing as multiplying rational expressions, except for there's one extra step. Remember when you learned how to divide fractions? Let's say that you had 2/5 divided by 3/7. And this is what your elementary school teacher taught you. Is your elementary school teacher said to change the division into multiplication and then flip this fraction over. Make the denominator the numerator and the numerator the denominator. That's how you multiply fractions. So you leave the first one, turn the division into multiplication, and then flip over the second one. So it's 7/3 instead of 3/7. And then you multiply. 2 times 7 is 14, and 5 times 3 is 15. So 2/5 divided by 3/7 is the same thing as 14/15. So that's the same concept that we're going to apply. So we're going to add an extra step in here. We're going to throw in step 1.5 here. Step 1.5. And that is change to multiplication and flip over the second fraction. Okay? Meaning the one on the right-hand side. So we're going to follow this procedure. We got a problem right up here. Step 1 is the same as multiplication. We're going to factor all of the numerators and factor all the denominators. So this numerator, two numbers multiply to 15 add up to -8, -5, and -3. So we're going to have x minus 3 times x minus 5. Denominator, this is a special case of factoring. This is where half of the middle number squared is equal to this. That's called I call it a binomial squared, okay? Two numbers that multiply to 25 but add up to 10 are +5 and +5. So we actually have x plus 5 times x plus 5. And now, two numbers that multiply to 21 but add up to -10, x minus 3 and x minus 7. Okay? Two numbers that multiply to 35 and add up to 12, +7, +5. So we got x plus 5 times x plus 7. So that's step 1. All right, now step 1.5. We're going to change this this division into multiplication, and then these factors up here are going to come down to the denominator, and these factors here are going to go up to the numerator. We're flipping it over. We're going to bring over this one. Okay, so this is going to be equal to, bring over the x minus 3, right up there, x minus 3, x minus 5, times x minus 5. Bring those over x plus 5, x plus 5. Now, don't even think about canceling this x plus 5 with this x minus 5. I've already explained that before. You can't do that. It has to be exactly the same. All right, now we're changing it to multiplication. And now, the top is going to go on the bottom. X minus 3, x minus 7. The bottom is going to go on the top. X plus 5, x plus 7. And now, multiplying straight across basically just puts all 4 of these in the numerator and all 4 of these in the denominator, right? Okay, so I'm just going to draw that line. It's now one fraction, all multiplying. Now we can cross out things that are matching. In the numerator, so we got an x minus 3 in the numerator and an x minus 3 in the denominator, so we can cross those out. X minus 5 in the numerator, but there aren't any x minus 5s in the denominator, so we can't cross anything out. We've got an x plus 5 up here, and we've got 2 x plus 5s down here, but we can only cross out one of them. We can't cross them both out, 1 for 1. So if I cross out 1x plus 5, I get to cross out 1x plus 5 here. Now, I got an x plus 7, but I don't have any x plus 7s. I have an x minus 7, but I can't, but that doesn't match. So everything that's left, that's my answer. So in the top, I have an x minus 5 and an x plus 7 over an x plus 5 and an x minus 7. Okay? So this is my answer. If I've divided those two fractions, this would be the answer. And so now I got to identify my domain restrictions. Now this is interesting. X cannot equal. Now, here's our new step. Not only can x not equal anything that would make an existing denominator equal 0, x also cannot equal anything that would make a former denominator equal 0. So we have to look at our current denominator for zeros. We have to look at the things that were crossed out for zeros. And we have to look at what used to be a denominator. Remember, these two things, they used to be denominators. So those also cannot equal 0. Okay, so currently, so we've got x plus 5, so negative 5. X minus 7, so positive 7. Okay, now if we look at our old denominators, well, we've already covered x plus 5, so we're okay there. But how about x plus 7? Negative 7, right? Okay, so we can't even have negative 7 as x. And then our things that were crossed out. Well, we crossed out negative 3. So first of all these are vertical asymptotes. So we're going to put in VA on all of these. Okay? And then lastly, we're going to put, actually negative 7 probably isn't. We'll have to talk about that later. For now, just put vertical asymptote. But this is actually because I want your brain to get accustomed to it. But we're actually going to talk about this situation, this x plus 7, negative 7. We're going to talk about that later. Okay? So this x minus 3, so 3 is illegal. Why? Because there's a hole there, right? And lastly, we crossed out an x plus 5. Well, we already accounted for negative 5, right? We called it a vertical asymptote. So we're going to leave it as a vertical asymptote. We're not going to change it to a hole, okay? So that's it for this particular problem. I'm now going to put one more up, and I'm going to see how you can do with it on your own. All right, let's see here. Where did I put my notes down? There. Oh, that's not them. Put my notes around here. There they are. Found my notes. There we go. All right, we're going to do 10x to the 4th power minus 50x to the 3rd power over x squared plus 2x minus 35 divided by 2x cubed minus 6x squared over x squared plus 4x minus 12. Okay? So why don't you pause the video and then use these rules right here to solve this division problem right here. All right, hopefully you were able to work this out. I'll go ahead and work it out. Let's see how it turns out. All right, now up here, we got a greatest common factor that can come out. What divides into 10 and 50, right? Well, 10 does, right? So we can take a 10 out, all right? And then what goes into x to the 4th and x to the 3rd? Okay, well, the smallest number of x's, which is x to the 3rd power, right? So 10x to the 3rd. Well, what's 10 divided by 10? Well, that's 1. How about x to the 4th divided by x to the 3rd? Well, that's just x. Put an x. What's 50 divided by 10? That's 5, right? But this is minus 50. Negative 50 divided by 10 is negative 5. And the x cubes cancel each other. Okay, good. Down here, two numbers that multiply to negative 35 but add up to positive 2. positive 7 and negative 5. So x plus 7, x minus 5. Over here, greatest common factor. What divides into a 6 and a 2? A 2 does. How about the x's? There's 3 x's here and 2 x's here, so we can take 2 x's out. So x squared, all right? 2x cubed divided by 2x squared is 1x, or just x. And then negative 6 divided by 2 is negative 3. And then x squared divided by x squared, well, that just cancels out. Two numbers that multiply to negative 12 but add up to positive 4. Positive 6 and negative 2. X plus 6, x minus 2, right? And now, that was step 1. So we factored all the numerators and denominators. Now we're going to change the division to multiplication, and we're going to flip over the second fraction. So we're going to carry over the first fraction. So we're going to have 10x cubed times x minus 5 over x plus 7 times x minus 5 times, instead of divide, we're going to multiplication. We're going to flip over. So this is going to go to the top, x plus 6 times x minus 2 over here, 2x squared times x minus 3. All right? Now, I'm really only seeing one thing that can cancel at first. We've got an x minus 5 and an x minus 5. But there's no x plus 6 on the bottom. There's no x minus 2 on the bottom. There's no x plus 7 on the top or an x minus 3 on the top. So I'm going to rewrite the whole thing. 10x to the third times x plus 6 times x minus 2 over 2x squared times x plus 7 times x minus 3. Now, see this? This can be simplified. If we just did 10x to the third over 2x squared, can't this be broken down? 10 divided by 2 is 5, right? And x to the third divided by x squared, 3 minus 2 is 1, so that's just 5x. And because it's not in the denominator, that means it's automatically in the numerator. So this 10 and this 2, they cancel to become 5. Both of these x's cancel, and 2 of these x's cancel, so we have 5x in the numerator. And so our final answer is 5x times x plus 6 times x minus 2 over x plus 7 times x minus 3. Now, what can x not equal? Well, x cannot equal anything that would make the denominator equal 0. So, negative 7, positive 3, and now what used to be a denominator? Well, the x plus 6 and the x minus 2 used to be a denominator. So we also can't have these equal 0. So negative 6 and positive 2, negative 6, positive 2, and what was crossed out? X minus 5 was crossed out, so x cannot equal positive 5. That's because that's a whole. All these are vertical asymptotes. Vertical asymptotes, VA, VA, okay? And then lastly, don't forget about, oh no, there's no x's in the denominator, so this x is okay. We don't have to put 0 in there because that's a numerator, not a denominator, okay? And that's it for dividing rational expressions. If you're not sure, then maybe rewind or back up, watch these examples again, and I think you'll get it. Okay, especially when you get a lot of practice, you'll feel a lot better about all of this. That's all I have for you. All right, and I'll see you in class.